Hello, folks. It's Ron. Hey, welcome back to my series of residential network cabling videos on wiring the home properly. And in this one's part 7, which is telephone basics. So let's get right to work here and talk about basic phone systems. And folks, I'm talking about basic older analog phone systems that we is really installed about everywhere in the United States. And still a lot of us use it, although it seems like more and more of us have fewer and fewer landlines. And the sad thing about that is, those old landlines, one great thing about them is the power goes out in the neighborhood, those other things are still working. And we call those old phone systems public switch telephone networks, or, older guys will call them POTS lines or plain old telephone service. So it's just some older technology that's been around forever. And really, old phone systems really predate, transistors and all kinds of stuff. I mean, it's amazing how old that technology is. Just really kind of above what the old telegraph could do. But so let's talk about some of these phone systems and what basics you should know. And when you look at a phone system, it requires what we call a pair or two conductors in order to make that phone line work. And by the way, we're not going to be talking about voice over IP, and we're not talking about cell phones or anything, just old telephone line systems. So every line required a separate pair for service. And so if it had two phone lines, I needed two pairs, and four lines mean I had to have four telephone pairs or coming to that building. And older buildings, we had hundreds of pairs coming into them. So and when you look at the two conductors that make up that phone line, the two conductors are referred to as a tip and a ring. And the terminology goes way back in the day when you always had to go through an operator to make a phone call. And you see the old movies where the person's cranking the phone at first. And what that basically did would light a light on a switchboard back here at an operator station. And they'd be sitting there at that central office going, okay, yeah, someone's calling. And they'd have a headset on with a little pluggy thing that plugged into that console. And they could actually talk to you and then switch you over to whoever you wanted to talk to. And so the two conductors went out to the home. One of the conductors was connected to the very tip of this little pluggy that they're utilizing. And the second conductor went out to the home was on an insulated ring, and they're separate of each other. And the sleeve in that system was the ground. And that's where the terminology tip and ring came from. And it actually means positive and negative because the phone companies are using DC, not AC, to provide talk power to that system. And again, that's how come your phone still worked when the power went out in the system in the neighborhood, because again, the phone companies are using DC to power that. Now, so the term is again tip and ring, and it means again positive and negative. And it was very important in these older analog phone systems that did not get flipped anywhere between the central office and the home out there. And if it ever did, a lot of these older phone systems actually wouldn't work. You could dial out on them, but they wouldn't ring for you. So it was very important they kept that polarity the same. And the term tip and ring, older technicians, this is the 19 teens and the 1920s. Nobody understands AC/DC, and nobody understands polarity. So by utilizing this terminology, they can kind of keep that straight in their mind, so to speak. Now, the DC voltage is not a huge thing here. But AC is kind of interesting. The only time you'll get shocked in a phone system typically is when the phone's ringing. And when it's ringing, there is some AC present on that telephone pair as well. And we will tell you it's going to vary depending on how far away you are from a central office, but typically we'll tell you it's somewhere around 90 volts AC. But the frequency is considerably less than normal AC. A lot of us know that normal AC is 60 hertz. And you understand, old phones have mechanical bells in them, and clanger bells basically. And if they put a 120 volt or 90 volt signal down a cable at 60 hertz, that bell would try to clang at 120 times a second. And so your ear would hear actually a solid tone. You wouldn't actually be able to pick up the cadence in the bell. So by dropping the frequencies down, also we can hear the cadence in the bells. And it's a unique sound. I mean, throughout the world, when people hear a phone ringing, they all go, "Hey, dude, that's a phone ringing." So it's a pretty common thing today. So it is quite a bit less in frequency. Now, the the old human body operates around 60 hertz in frequency as well, and by dropping that frequency down, it actually helps our body tolerate that. So if you ever get shocked by a phone, that's usually one of those things you get a pretty good tingle out of the deal, but you may not want to be sitting down like normally C would get you. But be careful, folks. There is some voltage present on that phone line, but specifically only when the phone is ringing. And it's one of the reasons why we would not want to plug a computer into a phone line accidentally, because if it rang and it was on the right pair, it could actually burn up a network interface card in a PC. You know, phones have changed drastically compared to what they were just 20 years ago. And, you know, we make them do a lot of things we never thought they would do. But what is it at its basics? Well, at its basics, it's a microphone and a speaker. And its job is to take a sound, convert it to an electrical impulse, and through a conductor or a pair, send it across a wire, and on the other end, turn it back into sound through a speaker. So it's all about making sound is what it's really kind of boiled down to. And you should be aware of any phone you use or purchase here in the U.S., or it really needs to be compliant with the FCC here. If it's not, they're afraid that, you know, if you used it, it might actually damage your system. And you'll find an FCC number on the back of every landline phone you find. Okay, and a couple things you ought to know about that phone. And one is that you know, its job is to recreate sound. And what's interesting about that is phone companies do not try to recreate all sounds. And if they did, their equipment and wiring would have to be a whole lot better than it is. And so they basically try to recreate basic voice patterns of speech. And between what we call 400 and 3400 cycle frequency sounds or tones. And I think a lot of you know that all sounds are waves, and we as humans can hear roughly 20 to roughly 20,000 hertz. And it's like the perfect human, the day you're born kind of thing. And as you all know, we lose our hearing as we get a little older. So I tell people this is how come you all sound pretty good singing on a phone, because that phone company ain't recreating the highs or recreating the lows, just kind of that mid-range. Now, the second bullet here is something you ought to really know, and that's called the ringer equivalency number. And what the heck is that? Well, you know, and I know you all have done this. You got on the phone with somebody and you say, hey, honey, pick up the phone in the other bedroom. And then they got on the phone with you. What happened to the level of the voice conversation you're having? And the answer to that is it dropped. Okay? And if somebody else gets on another extension in the building, it goes down even further. So and you get to enough people on the phones, nobody can hear anybody. Okay? The other problem with having too many phones hooked up in a building is that the ringing voltage coming into the building may not be strong enough to ring all these darn phones you've installed. So how do I go about figuring out how many phones to put in the building? Well, here's how you do it. Well, every landline phone right next to that FCC number will be an REN number as well. And old rotary dial phones, if you remember those, used to have an REN number of 1, and the local phone company back in the day would let us have a total load per house of 5. So if the REN number on the phone was 1 and they allowed 5, well, then obviously 5 phones could be used, and all 5 of us should be able to talk to Grandma. Now, if we got beyond those numbers, well, then we'd start having issues. Well, today, the new digital type phones are that REN number is dropping way down, and you'll find that it's like 0.2 today. So you might check with your local phone company and say, hey, what's the max REN load you're allowing per household today? And let's say they come back and say 3. Well, if they said 3 and your phone is a 0.2, well, 0.2 goes to 3, actually 15 times. And technically 15 phones could be used in that building. And again, we should be able to talk to Grandma technically. Now, when we go beyond these numbers, that's when you have to start thinking about installing a phone system for that building. And PBXs, private branch exchanges, these are just basically a telephone system that you will then amp and fire up all these extensions. Because again, the phone company is only really required to get it to your side of the home. And for basic service, you go beyond that, well, then there's a lot of things we could potentially do for you there. Okay? So that's what the REN number is and why it's kind of important to you. And the sampling rate here we show is 8,000 times a second. You know, see that they do sample in line quite a few thousand times a second. It's roughly basically twice the highest frequency in order to create a sound properly on the other end. And the way we've dialed out is really changed significantly here. Well, I guess it really has if I think back about it. When the touch tone has been around like 40-some years. Prior to that was the old rotary dial type phones. And if you remember the old movies, or you might still have one of those, The way they worked is you put your finger in a hole on the phone and rolled it to the stop and pulled your finger out of the phone. And if I put it in 3 and rolled it to the stop, the phone went click, click, click. And if I had it in 5, I got 5 clicks, and 9 got you 9 clicks. And the old phones, you don't even need the dialers. You can take the phone, hook the handset off the phone, hit that little button on top of the phone, 1, 2, 3, and wait a half a second, and hit the next number, and wait a half a second. That's all that phone was doing, is just a little interrupter switch in it anyway. So, but the touchtone phone changed things quite a bit, and we refer to it as a dual tone, multiple frequency system. And essentially, that sounds crazy, but what it actually is the touchtone phone, each button makes a unique sound. Okay? And the way they do that is if I push 1 on a keypad, that phone takes 2 different frequencies at 2 different tones and combines them together. And when they get combined, they make that unique sound. And so every button, again, on the phone will make a different sound. And that's how come today, if you recorded dialing a number, and you picked up a phone and got a dial tone and played it back, it will dial the phone for you. You'll find out that the phones aren't actually all that smart. So, I don't know if this is true or not, but I was watching late night TV a few years back, and it said that the touch tone phone saved the average human 400 hours in dialing in their lifetime, just because the old rotary dial took so long to actually dial a phone number. But you know what? Those old rotary dial phones, that was back when we were proud of what we made. And those things were designed to last years and years and years. As a matter of fact, if you'd like to, you can go make a fashion statement, buy a phone out of the 50s or 60s, and as long as you got pulse technology still going to the home, you should be able to use it. Okay? Now, that phone line is going to be coming to the home or apartment or wherever it is, and either airily or underground to the outside of the building. Okay, and a lot of new construction is obviously underground for safety reasons. Usually out of one of these little green-looking pedestals that you'll see out there, and it terminates to the side of the building at what we call a demarcation point. Now, 40 plus years ago, this has been a porcelain terminal shoved up underneath the eave of a house. Today, it's always going to be a gray-looking box, and we call it a network interface device, or if you hear the phone boys ever talking about their NID, that's what they're referring to. Now, the DMARC is simply a point on the building where they own it, and from there on in, you own it, okay? Old Ma Bell days, they own the wiring in your house and everything too, and that's why they'd actually come in the home and fix things. But today, that's not true. They own it at the side of the home, and from there on in, you're required to take care of it. So you look for this gray-looking box, and from this box, you are going to pull cable into typically a low-voltage panel of some sort into the building, and from there we'll home-run wire out to all the different phone jacks we're going to install in the building. And as a general rule, I tell everybody, make sure you don't leave your cables exposed on the outside of buildings. Hide it if all possible, or put it in conduit to make sure it doesn't get damaged, because things happen, so to speak. And where in the old days, we would come out of this box and go into the first outlet on the first floor and splice that cable, go fed the next outlet, splice that cable, and go fed the next outlet. And that's referred to as daisy chaining of cable, which we typically don't recommend today. Okay? Now, when you look at this gray box, it's split in half. Half that box is the telco side of the box, and technically you're not allowed to get into that. Now, you'll find a nut driver will open it up pretty quickly for you if you want to take a look at it. And you're going to find nothing but a simple connection going from their side of the box and plugging into this thing on the customer side of the box. And that's the actual physical demarcation point, that right there. And that is actually a testing point. So if you have issues, do I have dial tone in the home or outside the house? If I have it here, well, then I know the problem's in the house someplace, because we're getting dial tone to the side of the building. Now, these are typically still red, green, yellow, black on older versions of this, although newer ones will be the new category colors that we'll talk about here in a second for category 5, and 6. And when you look at the red, green is supposed to be line 1, and yellow, black was meant for line 2 on that box, okay? So again, we're going to find a place from that box and find a place to mount our low voltage panel, bring cable in. Now, the cabling we're going to use is considerably different from the old telephone wire. This old telephone-looking stuff, what we call quad wire, if you don't know, this stuff is not allowed to be used inside of walls anymore. You can only use it outside of walls. It's not fire ready to go on the wall anymore. So we call that old POTS wire, or guys would call quad cabling, or red, green, yellow, black type of telephone wire. Now, in that type of cabling, line 1 is always red-green, and line 2 is always, yellow and black. Line 3 was white and blue, and if you had it, line 4 was brown and slate back in the days. Now, today we're using Cat array cables, and as I said, I think earlier, Cat 3 is kind of the minimum the FCC would expect you to use. 5E is really probably what I would tell you to do at a minimum today. But in that category, in that cabling, that wiring is totally different colors, and the pairs are blue, orange, green, and brown. And so if you look at the chart on the left here, it says line 1 ought to always be blue, okay, and line 2 ought to be orange, and line 3 ought to be green, and line 4 should be brown. Now, do the devices know what color the wire is? And of course, the answer is no. So would any pair work in a pinch? And the answer is yes. As long as both ends of the cable are hooked the same, but the same pair should kind of work, okay? And you'll see that this is comparing old colors to new, and it shows me that if I am using this thing, and I tell people still use them, if it's going to be an outlet in a garage out there someplace, what the heck. But it's going to be the old colors in here, so I'm going to take the green screw in here, but I'm going to hook it up with the white with the blue stripe in the cat array cable I'm utilizing. And the red screw in here would get hooked up with the blue with the white stripe. So that's how we go about converting old to new if we had to. And you'll notice on the chart on the left and in the middle there that the white conductor of that cat array color is always the tip of the pair, and the colored version of it is always the ring of the pair. Okay. Now, on the far right, what you see here is a wiring diagram we call USOC wiring, USOC. The little letters stand for Uniform Service Order Code, if you care to know what that means. And what that is the picture of a phone jack, okay, of an 8-wire phone jack, okay, which we typically would consider a RJ45. And the RJ in this case stands for Registered Jack, and believe it or not, the FCC has a lot of them. But typically all we see in phone circuits are RJ45s, and more typically actually RJ11s, which we'll talk about in a second. And we always know when we look down inside of a jack or a plug that the middle pins are always going to be line 1. Line 2 is right on the outside of that. And if we had a 4-wire plug or jack, that's all we got. And of course we had an 8-wire pins. Pairs 3 and 4 are on the outside of those. And again, we call that USOC type of wiring. And by the way, what you're looking at there and is the face of the jack, okay? If you want the relationship of the pluggy plugs into the face of the jack or into what you're looking at here on the screen. So that is actually the face of a jack. I've had people think that that's the face of this plug, and no, it's not the face of the plug, okay? All right. So USOC wiring is how phone circuits have typically always been wired. Okay. Now the little plug that we use on the end of the cables, this is referred to as an RJ11. As I said, there's many variations of this, but we don't see most. And when you look at this little pluggy, it can have change as far as number of pins that are in it, and so we call it 6 position 6 contact or 6P6C. That means there's 6 slots in the plug, and there are 6 pins for 3 phone lines because each one needs a pair. You can get this with just 4 pins, and it's still got the 6 slots, okay, for 2 phones. And you can get it just with 1 pair for just 1 phone. And so the physical size of the connector actually never changed. It was just the number of pins in it. So they're actually interchangeable just depending on how many phone lines you're actually needing to use, okay? And again, this is USOC, I said a minute. Line 1's right in the middle, then line 2, then line 3. And as far as the polarity here, as the tip and ring thing goes, I've been trying to find out for years, and who knows, maybe somebody will call in and make a comment why this goes tip, tip, ring, from from left to right. And the answer is I don't know. And I just tell people, whoever engineered this years ago is long dead, and just drink the Kool-Aid, because as far as I know, there aren't any variations for it. So, but that's the relationship of the tip and rings in the pluggy or the jack itself. Okay. Now, if you ever want to go out and buy one of these little telephone cords, or if you look at one you're utilizing, or if you need to fix one, if you hold the 2 plugs side by side like this together, and you look at the coloring and how they actually wired it, you're going to find out they reverse wired it. And this seems kind of odd, but what's going on here is that we did need to flip tip and ring in these old analog phone circuits, but the only place we wanted to do that is from the outlet room to the phone. That's it, okay? And if you look at these 2 plugs, the tip and ring is the same for the inner and outer pairs, the same on both sides. But you look at the outer pair, you look at the tip of that outer pair, pin 1, you'll see that it actually is terminated at pin 4 on the other plug into the ring position of that outer pair. And of course, pin 4, or the ring of that outer pair, is then connected to the tip on pin 1 on the other side. So they're actually mirror images of each other. So we did need to do it, but we only wanted to do it there. And any place else, that was a problem. And if you want to think of this as transmit to receive, you kind of can. And, in computer networks, a lot of us know that 10 and 100 base T, we're only using 2 of the pairs. One's a transmit, one's a receive, and we do that flipping, but we do that in the equipment, not in the cable. Where in old phone circuits, we actually did it in the cable. So today, though, you know what? Digital phones are really not polarity sensitive, so they really don't care. If you straight through wired, a digital phone should work. Then the reason these still are is because people still have old analog phones, and those things were made back in a time frame when we were proud of what we made, and they were designed to last years and years and years. So as I said, you can go out and buy a phone out of the 40s or 50s and still use it today, as long as you got pulse technology coming into the building. Okay. And when you go to make up these connections, I mean, you can make very simple connections. I mean, wing nuts will work fine if that's all you got in a pinch, or twist them together the conductors and wrap it in tape will work fine in most cases. It's not much of a connection. It's not what a phone guy would do, but and one of the simplest ways of making up phone connections are to utilize things like these. We call them jelly beans. Other people have different names for them. There's a number of people who make these kind of connections. Today we use what are called IDC connections. Okay, days gone by, you would have always had a screw like this that you would have had to strip a conductor, wrap the wire around a screw, and tighten the darn thing down. And today, basically, all connections are V-notch cutting blades that you take a conductor with the insulation on it, you set it in that V-notch cutting blade, and you drive that conductor into that cutting blade, utilizing what we refer to as a punch-down tool typically, and it bites through the outer jacketing of the cable and bites into the copper, and again, we call them insulation displacement connections. So there you go, a fancy term for the connectors, but virtually everything is IDC. So patch panels, category jacks, phone jacks in this case, a lot of them are IDC type today, again, utilizing punch-down tools to terminate them. Now, these have a little bit of silicon-like material inside of them, and so they're weatherproof, not waterproof. You're not going to stick these in a bucket of water or bury them in the ground technically, but they're for making low-voltage connections for phone circuits. And the difference between the 3 colors you see here, the blue and the yellow basically do the same wire gauge, 22 to 26 gauge. The reds go up to 18, and well, actually, this is 19, but you can get 18 in it. And if you put 18 gauge cable into a yellow or blue, and it'll look like it, it'll feel like it made a connection, but you're going to find out it didn't. And I occasionally see security guys utilizing these things, and again, they pull a lot of 18, but a lot of cases, our phone wire is 24 gauge usually. So these things are for tapping and splicing phone circuits. And if you could imagine along the length of a telephone pair in a building now, anywhere along that length, for old phone circuits, basically I can tap into that line and feed a phone, okay? But I have to cut into the tip and the ring and go feed an extra phone. So what the red ones do for me is they tap a line. And basically I would take one of those conductors I want to tap, I'd cut the cable, take those 2 ends and put them inside of a red one. And the red ones have a hole for a third conductor, which would be tapping off to that phone I'm going to feed. And when I crunch it down with a pair of pliers, it'll make them all 3 one again using those IDC connections. And, we sell a plier, and everybody else has got a plier, and, a pair of channel locks will probably work fine as long as you don't crush the little plastic housing of the jelly bean. Now, the yellow ones, what they were designed for is splicing only. So if you cut this guy's wire for whatever reason, you just need to put the 2 ends back together. The yellow only accepts 2 conductors. Now, you could have used a red one. It just wouldn't have had a third one out of it. But, matter of fact, most cells are actually in reds. And the blue one is a little on the sneaky side. It taps a line like the red one. But you know how we had to cut the wire to use the red one? The blue ones have a slot running all the way down to one side of them. And I'm going to take this conductor, I'm going to tap, and I'm going to put it inside that slot. and there's a hole on the end of that little blue one that I can lay a tap wire out of. And the big difference is that when I crunch that blue one down with a plier, it does not cut the wire you're tapping. So you can tap a line without disrupting somebody's service. And unless you're the United States government or one of those kind of guys, like I said, most cells are in red ones. But I could use these to basically jelly bean all the telephone connections that go off to feed all these different phone jacks, and it should work. Okay. Now, if you want to step up your game and buy something fairly simple at some retailer, you can buy these things for usually under $40. And these are just basically little plastic boxes that you can mount someplace. They normally do phone and video for basic over-the-air TV or cable TV applications. And so I won't talk about the splitter in this thing, but it has a telephone bridging board in it. And if you can imagine, there's like 9 connections on this board. And on that board, one of them will say from demarcation or incoming line or something like that. And I would bring that cable from that demarc on the outside of the home, that NID, and run it into here and terminate it on that telephone board, again, utilizing a punch-down tool. And, watching my other videos on how to use punch-down tools and how to make these connections up, you'll find them in like my smart home series and things like that. And bringing up to 4 incoming phone lines is what they're designed to handle, okay? And this board splices all these other connections together. So you can imagine the blues and the greens and the oranges are all the same. So you can then go off and feed technically 8 phones with up to 4 different phone lines throughout the building, which is usually plenty for, again, most single-family applications, okay? If you go out and buy a low voltage panel, fair size panel for maybe a little bit bigger job or intermediate job or maybe something very large, you can also find companies that sell modules that go in like this. And again, it's usually a video and a phone thing kind of tied together. So it's got a splitter on it. And then this green board in the middle is very similar. It's got 10 connections on it. They're all spliced the same. So an incoming phone line can come into really any of them. And then I can run 9 category wires out to 9 different phone jacks in a building and basically splice all those together. Okay. And another way of doing this, if you want to maybe look into more structured wiring ideas for the building, is to utilize what's referred to as a cross connect. Now, in those other examples, we're kind of interconnect. We're bringing a dedicated run, and that line is going to be nothing but a phone line because that's what it's terminated to, is back at the phone board. Well, you can also utilize what are called cross connects in a lot of these residential panels today too. And so here's an example of kind of the big brother to that board you just saw a minute ago. Now, it's got 2 other green boards. The middle green board, the big one in the middle here, is for the incoming phone line. And that category wire that comes in the panel here and feeds that connection that says from demarcation, again, can bring up to 4 separate phone lines in from the demarc, is the incoming phone board, so to speak. Okay, the board to the left of that is actually a Category 5E rated board that feeds jacks out here at the outlets in the rooms. Okay, and this is a Category 5E jack, and that jack could be phone, could be data. In this case, I'm making them phone, and so if you can imagine, all we need to do to make this outlet in the room a phone jack is to grab some of these gray little jumper cables that one of the panels would come with. And you can see we're plugged into the second position on that little green board to the left, which again, say, feeds this jack. And you see how I've got that plugged into the big green board where it says 1, 2, 3, 4. Now, if I had 4 active phones, it would be trying to jump all 4 lines to the outlet. Now, if I only had 1 active phone, it's only going to jump line 1. Okay? And I can now take a telephone and a typical RJ11. If you don't know, this RJ11 will plug into this 8-wire jack, and we hit the 4 middle pins in the jack. So that jack can be used for phone services, okay? And you'll see right below it that other gray cable that I'm using as a cross-connect. It's plugged into, say, maybe the connection next to it. You'll see it's plugged into the outlet on the big green board that says 1 and 4. And that means it's only jumping line in 1 and 4 to that particular jack, in that phone jack in that room. And you can see by just changing where I land these jumper cables onto the big green board, I can make pretty quick changes to what's going on here at the outlet without ever having to really rewire nothing out at the outlet. So that's, again, one of the advantages of having structured cable. And what's really neat about this is if little Johnny finally moved out of the house and you wanted to make this thing a data jack, Well, I'd get rid of them gray jumper cables and plug a Category 5E patch cord into that, and then plug that patch cord into a router that sits in this panel. And now this outlet can be data if I choose to. So, again, one of the beauties of having structured wiring. And again, these are usually bigger panels that we're going to mount someplace, again, in the building, okay? And lastly, as far as phone connections are concerned, if you haven't used one or seen one in the past, these things are called 66 blocks. Kind of a dying breed, and I tell people if you find these in a home, it's usually because whoever owned that thing ahead of you was a phone guy and you happen to use one. And if you want to learn how to terminate a 66 block, I'd tell you go YouTube that. There are lots of ways of doing this, depending on what you're trying to accomplish. When you look at a 66 block like this usually gets mounted on a bracket someplace that we can run wire in and around and behind that block and wire it nicely into that block. And they come in lots of flavors, and one being what's called a split 50. And if you can imagine, if you could take that metal clip off and you wiggle the two connections on the left, they'd be the same, and the two on the right would be the same, but there was no connection between the ones in the middle. And typical install would be to bring an incoming cable to the left side of that block, an outgoing cable to a workstation off the other side of that block, and then they would put a bridge clip here in the middle to make the connection between the two. And they did that because if they ever needed to go work on that phone out at that workstation, they didn't want to get shocked, they could come back here and pull that bridge clip and that phone would be dead out there. And otherwise they'd be ripping wire out of the block to disconnect it. So typically we bring cable from, again, one side of the block, catch these little hooks on these little connections inside that 66 block. A punch down tool, again, with the 66-bit in, will drive that wire down into that IDC connection and make that connection for us. And in this case, usually trimmed off the conductors for us as well. But as I said, there's lots of ways of wiring 66 blocks. So you might look into that if that's, maybe you're doing a strip mall or something like that. I don't know. All right. Well, hopefully that helped you with some basic phone terminology and what to think about when you're wiring those things up and, color codes and things like that. Really appreciate you guys watching the channel. Do me a favor, if you haven't subscribed to it, please do. And thanks again for watching. I'm Ron with IDEAL, and I'll plan on seeing you on the next one.